Hi, Assalamualaikum and a very good morning. Today we are going to present the title for our project is MRI scanner. We are from section 1 and section 2 and our group number is group 8. So the members for this group is Recher, Egoh and REPAI, Muhammad HAZIQ NURHAQIM, Muhammad AMIRUDDIN, NURUL FARISYAH and NORSAFIRAH. So today for the introduction, in this group project, we are going to do the prototype of MRI scanner. So MIR is a non-invasive imaging technology that produces three-dimensional detailed anatomical image. In a practical way, the evaluation of three-dimensional magnetic field pattern produced by the current flowing in a coil can be performed with the Biot-Savart law. So for the problem statement, MRI scanners are commonly used for illness detection, diagnosis, and treatment monitoring, but they come with a number of hazard and issues. So the problem that we can see is how the molecules surrounding and chemical composition may influence the time it takes for the protons to realign and the quantity of energy released once the procedure start. So we going to the objective. So for the objective for this project is to ensure the movement of the electromagnetic field in the MIR system. Next to the analysis the atomic particle that attract the magnetic field in the body. And finally is to measure the energy released by protons realigning with the magnetic field. I will pass to the other members for methodology.
Hi, my name is Muhammad AMIRUDDIN. So I will present about the methodology of our project. Firstly, the methodology present by the flowchart for the MRI scanner. We have a computer, go to the control equipment. After that, go to the superconductor magnet, gradient coil, whole body coil, receiver coil, and data collection. After the data collection, it will go back to the control equipment and the computer. So, uh, the plot diagram for this MRI scanner is firstly it go to the scanner, data execution, next pre-processing stage, next image reconstruction, display render, and the display of the MRI. So, in this project, water, which contains photons, hydrogen atoms, makes up around 70% of the human body. Photons are commonly aligned in the variety of ways. However, they become polarized and face the same direction when they approach a strong magnetic field, uh, especially a static magnetic field. When radio waves are used, all of the protons' orientation can be modified at once, which is we call it magnetic resonance, and the protons will return to their original configuration after some time. So, based on this idea, it used in the MRI scanners to allow data collection and control equipment to produce image of change in the amount of energy generated by the proton as they return to their normal condition. So, the brightness of the image of place where the protons do not revert to the normal rapidly versus normal areas can then be distinguished. As a result, MRI is particularly well suited to assessing soft tissues in the brain, spinal cord, and torso. Blood vessel images are extremely simple to obtain.
Hello, good morning to Sir Xavier and all my friends. Today I will do a demonstration about our prototype, which is a MRI scanner. Okay, as you can see here, it looks like MRI scanner, right? Okay, what is MRI scanner? What is MRI scanner stands for? MRI stands for magnetic resonance imaging. It's often used widely in medical field, of course, uh, especially in disease detection. Okay, such as you wanna scan if you have a breast cancer or not, and lastly, treatment monitoring. Okay, the process of MRI. How the process? First, okay, when the patient arrives at the hospital, the radiologist will ask the patient to put on a gown. A gown means, the traditional hospital clothes, okay? And if you guys know, there is no metal allowed when you are scanning here, because you know that it's very sensitive when we do the scanning process, and it has a metal object. The MRI scanner will face some problem, like it can detect well because of that metal object. Okay, after that, radiologist will help the patient to lie down to provide space here. Okay, the patient will lie down here with a gown that they were before. Okay, and before that, patient will be given an injection of IV contrast liquid to improve the visibility when scanning process is working. Then after that, the patient will listen the instruction via the intercom that have been controlled by the radiologist. And when the radiologist asks the patient whether they ready or not, and after the radiologist get the permission from the patient, when the scanning process is complete, the radiologist will check the image, and until they satisfied with the result, and after that the patient can go home. And lastly, an appointment will be set for the patient to get know about the result of the MRI scanning. Okay, that's all about the process of MRI scanner.
I will add some information from my previous demonstration. So in MRI system, radio frequency receiver phase array coils are utilized to pick up the signals generated by the nuclei with a high signal to noise ratio and a wide range of sensitivity. The right selection of coil shape and typology has a significant impact on the quality of the pictures that are produced. In this study, we provide a quick coil modeling technique that enables very accurate phase array coil design in order to calculate the mutual inductance between the array coils and the magnetic field pattern accurately. The proposed method makes use of magnetostatic analysis, and finally we create a unique phase array coil using the simulator that consists of macam pelik je ayat dia. Recher. Tak. Jadi aku habis ayat ni. In order to calculate the mutual inductance between the array coils and the magnetic field pattern accurately, the proposed method make use of magnetostatic analysis.
Hi, my name is NORSAFIRAH binti ISHAK. I will talk about the analysis and discussion for this project. MRI creates a comprehensive cross-sectional image of interior organs and its structures using a powerful magnet, radio wave, and a computer. The shape of the MRI is like a long tube with a table in the center, and MRI also identify it by using its in depth and scientific function to accelerate the speed at which protons realign with the magnetic field. MRI also a new diagnostic imaging technology that doesn't need radiation exposure. So from the discussion, MRI is a harmless alternative to X-ray, angiography, and the CT.
Hello, my name is Recher. So I'm going to present to you the conclusion for this MRI scanner. So in conclusion, we have shown how to use MRI to generate and measure signal from water molecules in the body and as well as providing images of the inside of our bodies. And Biot-7 law technique is very important in obtaining clear result of MRI scanner. Biot-7 law is mostly used to calculate the electromagnetic field pattern in the MRI scanner as it is suitable in and help in finding the phase array magnetic field pattern upon the coil dimensions. Biot-7 law also play part in the enhancement of coil sensitivity maps on the simulated data and also image enhancement with homogeneity. That's all from our group. Thank you.